Today we're doing section 10.7, part 1, which is complex numbers. And of the objectives that we're going to do 1 and 2 today. And in the next couple of lessons we'll do objectives 3, 4, and 5. So let's look at what objective 1 is. Express square roots of a negative number in terms of I. This means we're going to define what a negative square root means, and we can now take the square root of a negative number instead of it just being not real. And then 2, we're going to add and subtract complex numbers, and we'll get into what complex numbers are in just a second. So let's look at imaginary unit I, a couple of definitions here. When we took the square root of a negative number, we kept saying to this point that it's not real. That's because it's imaginary. And they created this imaginary unit I, and it is defined as I equals the square root of negative 1, where I squared equals negative 1. This part will come in a little later. Right now we're just going to be worrying about this. I equals the square root of negative 1. We'll do this in future sections. And that means I can take the negative out of a square root by calling it an I. So the square root of negative 1 equals I. And here's how it works. It says if b is a positive real number, then the square root of negative b equals the square root of b times the negative 1, square root of b times negative 1, which is the same as the square root of b times the square root of negative 1. And since the square root of negative 1 is I, we can write it as I square root of b. We won't ever write it like this because it gets confusing if the I is underneath the square root or not. So write it like the second one, I square root of b. So let's look at example 1. It says write as a multiple of I. So we got the square root of negative 9. Again, in the past we've had to say this is not real. We can't take the square root of a negative. Well, now we're going to be able to take the square root of a negative. We're going to be able to rewrite this as the square root of 9 times the square root of negative 1. And since we know the square root of negative 1 is I, and we also know the square root of 9 is 3, we can get our answer as 3I. And that's it. B, you just got the square root of negative 3. Again, we can rewrite it as the square root of 3 times the square root of negative 1, because negative 1 times 3 is negative 3 still. And that becomes the square root of 3 times I, but we don't write the I behind it, we write it in front of it, so it is I square root of 3. And you can kind of see a pattern. Anytime I have a negative under a square root, I end up with an I out front of the square root, or just an I with the answer, because this one, part A, broke down to square root of 9 is 3I. So if I look at C and use my shortcut, I know I got a negative in there, so I know I'm going to end up with I equals the square root of 80. The square root of negative 80 equals I times the square root of 80. And then I got to think about, can I simplify the square root of 80? Which I can. Square root of 80 breaks down into 16, square root of 16 times the square root of 5. 16 times 5 makes 80. And I can take the square root of 16. That's 4. So that equals I times 4 times the square root of 5. And I always write the I after my numbers. Before the square root, I write the I before the square root, but after whole numbers. So this thing is going to become 4I square root of 5. Yeah. There we go, 4I square root of 5. Pause here, try your checkpoints. When you come back, I will give you the answers. So checkpoint 1A is 8I. B is I square root of 11. And C is 4I square root of 3. Let's look at the next example, or the next page, and go through complex. So you got complex numbers here. These are numbers, complex numbers and imaginary numbers. It says the set of all numbers in the form a plus bi. These are complex numbers. A is considered the real part, bi is considered the imaginary part, and you always write it in this order. Anything that doesn't have an I goes first, anything that does goes second. And it goes on to say, with real numbers a and b and I, imaginary unit, it's called the set of complex numbers. The real number a is called the real part, and the real number b is called the imaginary part of the complex number a plus bi. If b is not equal to 0, then the complex number is called an imaginary number. So if we have 0i, it's really just 0 times I is just 0, so we'd have just the a, which would just be a whole number. So let's work on adding and subtracting these complex numbers. And the way it works is I can add the real parts and I can add the imaginary parts, but I can't combine the real plus and the imaginary. I can write it out as real part plus imaginary part, but I can't actually add the numbers. So let's take, in this first problem, 5 minus 11i plus 7 plus 4i, and let's take and rearrange so that we have the real numbers, 5 plus 7, and we can rearrange those because the commutative property says we can. So we get 5 plus 7, and we're going to add to that, because we got plus here, the imaginary parts, which would be negative 11i plus 4i. And let's just do our addition. 5 plus 7 is 12. We got plus negative 11 and 4. We can add it. You add it just like it's variables. The i's don't change when you add or subtract. So it's just going to be I, and we can take negative 11 plus 4, and we will get negative 7i. Okay, so we got 12 plus a negative 7i. Well, we know plus and negative is the same as minus, so it would be 12 minus 7i. Let's look at B. If I rearrange, oh wait, before I do that, the first thing I want to do, I have subtraction here. Negative 5 plus 7i minus, okay, negative 11 minus 6i. And with subtraction, we are going to always change it to add the opposite sign. So that means everything behind the subtraction. So I should put add the opposite sign behind. That's an H. That's a D. The subtraction. Okay, I'll abbreviate subtraction there. So I'm going to change this to add. Maybe, there we go. And I'm going to change all the signs here. So if these were positive, they would become negative. But since they're both negative, they're going to become positive. Then I can do the problem. And I do it just like I did A. So I can group, now I got plus here, so I can, and I got a plus 11, so I can group a negative 5 plus, whoops, I lost my pen, plus 11. And I can also, I'm adding now, I can also put my imaginary parts together, 7i, and this is a positive 6i, so it's plus 6i. If I add here, I get 6, and if I add 7 to 6, I get 13i, so plus 6 plus 13i. And that's all we got to do for B. Pause here, try your checkpoints. When you come back, I'll give you the answers. All right, the answer to checkpoint 2A is 8 plus I. If you get one I, it's the same as I, just like with the variable. And the answer to checkpoint B is negative 10 plus 10I. That's all for 10.7 Part 1. I will see you in class.